The first part of the National Climate Assessment is the executive summary, and this is where all the information about within the National Climate Assessment, that which is in itself a synthesis, is then further synthesized and reduced, so the main points can be summarized. In the beginning of the executive summary, they have a very short paragraph. The first thing they say is climate change is already affecting the American people. This is an important statement because when you take a look at the changes in climate that have happened, they already have had big effects on society. And climate change is not something that should be thought of as happening just in the future. They then say that certain types of weather events have become more frequent and or intense, including heat waves, heavy downpours, and in some regions, floods and droughts. So these changes that we've seen include changes in averages, but there's events that we really care about that have become more frequent. And we'll show you some of the data, for example, and some of the syntheses on changes in heat waves, heavy downpours, floods, and droughts. So already we're detecting an increase in the frequency and severity of all of these different events. Thirdly, they say that sea level is rising. Oceans are becoming more acidic, and glaciers and Arctic sea ice are melting. These are issues that we talked about earlier as the basis of ecosystem ecology and understanding how ecosystems work. And the evidence currently is that we know that sea level is rising and these oceans are becoming more acidic. Glaciers, Arctic sea ice, as a consequence of warming, are melting, and we're seeing reductions in the volume of ice throughout the world in these systems. Lastly, they say that these changes are part of the pattern of global climate change, which is primarily driven by human activity. Now, there's been question in the past about the linkages between human activities and climate change, and there's really no doubt at this point that when you take a look at the activities that humans have and what we expect climate change to be as a result of these, they match really well. So I'll go through some of the main highlights of the document, and I'll start with changes in temperature. This is their main summary figure for the changes in temperature that have already occurred, as well as the forecast changes. So these are from temperature records on a global basis, as this thin line here. So these are US average temperature projections. Here's year on the x-axis, and starts at 1900, and it goes to 2100. Right here on the y-axis, we've got temperature change in degrees Fahrenheit. So they'll set a baseline and then take a look at how temperature has changed from that baseline. Again, this is a US average. NCDC observations. So these are the observations that have occurred, and this is a historical record of temperature. And you can average that out. The different lines here are what we expect temperature to have been in the past based on models. And there's a lot of noise in the past, and we talked about some of those things like volcanic activity that generates aerosols, and that gives us interannual variation in average temperatures. And some of that variation is going to be hard to predict. The model shows what it looks like right here. And when we model past temperatures, they actually match pretty well to the average that you would draw of the current of the historical pattern. So already, if you take a look, we're looking at somewhere since, if we use 1970 or so, 1.5 degrees Fahrenheit. And again, these are Fahrenheit because we're in the US. So 1.5 degrees Fahrenheit, a change in temperature. They also show what the predictions are for changes in future temperature. So we've already seen on 1.5 degree. And there's a whole bunch of scenarios that are used that differ in essentially some of the assumptions, but also the model. And the assumptions are primarily how much emissions there's going to be. So how much future emissions in fossil fuels will there be? And so you can see, even at the lowest point, we're looking at a 4 degree Celsius or Fahrenheit increase in temperature. And under some extreme conditions, we can have up to 10 degrees Fahrenheit difference. So we've already seen a relatively large change in temperature, and 1.5 degrees is a lot. There's also forecast to be large changes in the future in temperature. So this is the historical reconstruction of temperature based on observations, as well as future projections of temperature based on different scenarios that have largely to do with differences in emissions. When we look at the observed U.S. temperature changes, this is the U.S. average. Each one of these bars is a decadal average, and there's variation, and you can see that it's been going up. There's been a lot of variation as far as how much warming or cooling has happened in different regions. The southeast has seen the least amount of increase. Other places like Alaska have seen the most. So in general, it's the high latitude systems that have seen the most increases in temperature changes. And you can see that some places have cooled slightly, and on a decadal scale we can get cool decades, for example. And other places have seen more than 1.5 degrees Fahrenheit difference. And you can see that a lot of that are kind of in the high elevations and northern latitudes that have seen the most warming within the US. The document also goes over some of the consequences of warmer temperatures. These are 10 indicators of a warming world. So what are we going to expect to see in a warmer world? Well, there's no one place to start, but if we start with the oceans are going to get warmer, so they're going to absorb a lot of heat, and we just talked about that. Sea levels should rise, in part because of melting of ice, but also because of thermal expansion of the water in oceans. We'll see a decrease in sea ice, which doesn't raise sea levels, but there will be a decrease in that sea ice, and sea surface temperatures should go up. As a consequence of higher sea surface temperatures over the ocean should go up, and we should see an increase in evaporation from the ocean. We know that a lot of that evaporation over the ocean ends up over land. We'll see higher air temperatures near the surface, and then a decrease in glaciers and snow cover, and higher temperatures over land too. So these are some of the expectations that we expect for a warmer world. Oceans get warmer and they're going to expand. Glaciers and snow cover decrease, sea ice decreases. In total, we're going to get increase in sea level due to thermal expansion and reduction in ice and snow cover. We'll have big changes in albedo as you go from ice and snow covered area, sea ice covered area into a darker surface. And then we really expect there to be a lot more evaporation from the oceans, and in some parts, more precipitation. A warmer world also is warmer in the spring and it's warmer in the fall. And that's led to changes in this frost-free season. So we've talked about and we know that in a continental system, in a seasonal system that has a cold and a hot period, the length of the growing season is determined in part by frost. It's when it starts to get warm and when it starts to get cold. And we've already seen big changes in how long this growing season, so to speak, has been. From 5 days in the southeast, roughly 10 days in the northern part of the US, 18 and 21 days in the western part. So we're seeing not only higher average temperatures, but that's led to an increase in the growing season. Another way to look at some of these increases in temperature are to take a look on a decadal scale, how many record highs we have relative to number of record lows. And you think under normal conditions, you expect to get the same number of record highs as you do record lows, and that leads to a ratio of about 1. Over time, what we've been seeing over the last few decades is an increase in the number of record highs relative to record lows. And now what we're seeing is twice as many record highs as lows in the US. One of those expectations also had to do with ice. And this is a synthesis of Great Lakes ice coverage. Starts in 1973 and goes to 2011. And the red line shows the trend. So here's the percent area that was under ice over time. And essentially, if you look over time, the Great Lakes have seen less and less of that area under ice. And as an example, they show Lake Superior in a year when it's really ice covered versus when it's open. And just from what we know about the energetics of a system, this is going to be a high albedo system, and it's going to maintain cooler temperatures. Here, it's a low albedo system, and you're going to see a lot more absorption of the water in the system and a lot more warming that's going to occur. It's one of those positive feedbacks to warmer temperatures associated with changes in sea ice and warmer air temperatures in the winter. Now, those are some of the changes that have been observed in temperature and the direct consequences of warmer temperature. They also show some of the links to greenhouse gases. We've gone through this in a little bit more detail, but here they're just going to show changes in global temperature and carbon dioxide. Here are global temperatures, 57 Fahrenheit, 58 Fahrenheit. And these are the data for global temperatures. And you can see really the shift to higher temperatures. And that's really paralleled this increase in CO2 concentration. We know that there are a number of greenhouse gases and a number of factors that affect global temperatures, but the biggest radiative forcing was for carbon dioxide, and that's why they put these two together. And you can see how clearly those two are matching. The document also goes through some of the forecasts of changes in temperature into the future. And I'll show just one slide here. These are some different scenarios that occur. And essentially they have 4 different levels of emissions of CO2. And we talked about that even if we were to shut off emissions, we still would have a warmer world because the CO2 is not going to be absorbed and sequestered instantly. It's going to take time. So you can think of this as being a relatively low emission. We really cut back our CO2 releases, and these are high emission scenarios. So under relatively low emission scenarios, we still get warming, but it's going to be on the order of 3, 4, 5 degrees, depending on where you are. Again, the high latitude systems like northern Alaska are going to see the most warming, and they're still expected to see somewhere on the order of 8 to 9 degrees Fahrenheit increase in temperatures. On the high side of things, if emissions aren't reduced, we're looking at over 10 degrees Fahrenheit increase in temperature throughout most of the US.